Congratulations, Geometry 11.8, the last section in Chapter 11. Hope you're as excited as I am to record this. So if you notice the last 4 videos, and we're in the same shirt, it's all the same day. So cranking these out this 16th day of April right now, and the last lesson here is the surface area and volume of a sphere. So we got a baseball picture there, surface area and volume for it. So our formulas. Surface area of a sphere, 4 pi r squared. So they talk about here the great circle. Ooh, oh, great circle here. The great circle is the circle that includes the radius of the sphere. Okay, so that's what it is when they want the great circle of a sphere. It's the circle that contains the or a radius. Okay, so you can't like draw one up here, and yes, that would have a radius, but it wouldn't have the longest radius. It wouldn't have the radius of the sphere. Okay, spheres will have radiuses, radii, just like a circle has a radius. Okay, a chord of a sphere is a segment that connects 2 parts of the sphere. It doesn't have to be a radius or a diameter. Okay, I can have 2 parts down here connecting in my sphere, and that could be a chord of a sphere. So just like a chord of a circle, you have a chord of a sphere. Okay, so 4 pi r squared, that is the surface area of a sphere. Now if you have a hemisphere, that means you have this, and then this is going to go around like that. So a hemisphere, that is half of a sphere. Half of a sphere, a hemisphere. Okay, that's where you get the hemispheres for the globe. That's where the term comes from. Okay, this surface area, again, you would have 1/2 of the 4 pi r squared. Okay, you'd have 1/2 of the 4 pi r squared, but then you have another pi r squared for the bottom. That is the base. So you have half of the surface area of a sphere, and then you have a base. So that would be 1/2 of 4 would be 2 pi r squared plus another pi r squared. So for a hemisphere, the formula is 3 pi r squared. So there's only one less pi r squared for a hemisphere as for a sphere, because you still have that base, you still have that bottom. So formula for a hemisphere is 3 pi r squared. For the whole sphere is 4 pi r squared. Okay, formula for the volume is 4/3 pi r cubed. Okay, we've had these volume formulas last 2 times dealing with pyramids of cones with the thirds on there. This has a third as well, except it's 4/3. Okay, so I think of the 4 from the surface area, and it's 4/3 pi r cubed. Cubic volume, because things are cubed. That's what reminds me there. So pi r squared, 4 pi r squared for area, because area is in square units. 4/3 pi r cubed for volume, because volume is in cubic units. Okay. So again, if you had a hemisphere, your volume would be 1/2 of the 4/3 pi r cubed. So 1/2 of 4/3 would be 2/3. Instead of 4/3, you have 2/3, half of that. So that'd be 2/3 pi r cubed if you had a hemisphere. Okay, so find the surface area of the solid. And the solid here is going to be spheres or hemispheres. So the surface area is 4 pi r squared. So 4 times pi times 5 squared. It is just that simple for us. So pi squared is 25. 25 times pi 4 is 100 pi. The surface area would be about 3.141593, 106 square centimeters. Okay. Okay, here's our diameter. So our radius is going to be half of that, 4.5. Half of 9. 9 divided by 2 is 4.5. So we need surface area is 4 pi times 4.5 squared. So 4 pi times 4.5 squared. There we go. And I get 81 pi, which is about 254.47. And that would be square inches. Surface area for a hemisphere. The diameter is 2 feet. That means our radius is 1. So surface area for a hemisphere is 3 pi r squared. So that would be 3 pi times 1 squared, which would be 3 pi, which is around 10, I believe. 9.42. Again, that would be in square feet. Let me scoot up. There we go. So 3 pi r squared, our r is 1, so 3 pi times 1 squared, 3 pi, 9.42 square feet. Here, 4 times pi times 11.2 squared. So we got 4 times pi times 11.2 squared. And 1,576.33 square meters, surface area. Square meters. Ooh, that's big. Not as big as the Earth, though. So what is the surface area of the Earth? Once you figure that out, and let me know. Text me or email me. Okay, volume. If the Earth was all flat. But surely it balances out between the above surface, above sea level, and below sea level. You think it all neutrals out, balances out from that? Would all the mountains, if they're cut off, would they fill the ocean? That's a good question. Find the volume of the sphere. So volume equals 4/3 pi r cubed. 4/3 pi r cubed. So we need the r, which would be 7.5 in this case. So 4/3 times pi times 7.5 cubed. 4/3 times pi times 7.5 cubed. So 4/3 times pi times 7.5 raised to the third power. And I get 1767.15. 1,767.15 cubic inches. Okay, I wonder how many cubic feet that would be. Well, in 1 cubic foot, there would be 12 cubed cubic inches. You don't like that, okay. 3, there we go. So that's only about 1 cubic foot, okay? So we have that many cubic inches, that is only about 1 cubic foot. Interesting. So here's our radius is 13, so 4/3 times pi times 13 cubed. So we need to change that to a 13. So 4/3 times pi times 13 cubed, and we get 9,202.77 cubic centimeters. Well, okay, how many cubic meters would that be? Well, there's 100 centimeters in a meter, so we'd have to take that answer and divide it by 100 cubed. You get 0.009 cubic meters. So it looks like a big number, but it's not really that huge. All right, let's just get going here. I said that before. 4/3 pi times 3.5 cubed. 3.5 cubed, and we get 179.59. 9 cubic centimeters. 10 inches. Here our radius is 5. To 5. So we get 523.60 cubic inches on that one. Sorry, that paper gets crooked. I know that annoys some of you. Would me, probably. Find the diameter of a sphere with a surface area of 144. So this is my S. So I know surface area of a sphere, pull up that formula, is 4 pi r squared. They want the diameter. Diameter equals 2 times r. So if I can find the radius, I can take it times 2 and find the diameter. So 144 pi equals 4 pi r squared. So let's divide by the 4 pi. The pi's cancel off on that side. 144 divided by 4, I think, is 36. So 36 equals r squared. So my radius is 6. Take the square root of both sides. The radius is 6. That makes the diameter equal 12. And we are in centimeters. 12 centimeters. Find the volume of a sphere with a surface area of 256. So they're giving you the surface area and they're asking for the volume. So from the surface area, we have to find the radius, and once we find the radius, we can find the volume. Notice that's a common link between both of them. So if S equals 4 pi r squared, 256 pi equals 4 pi r squared divided by 4 pi. 256 divided by 4 is 64. I knew that. 64 equals r squared. So r equals 8. Radius is going to equal 8. So that means the volume is 4/3 pi r cubed. I think I just thought of a shortcut I can tell you too. So that's 4/3 pi times 8 cubed. So 4/3 pi times 8 cubed. And we get 2144.66. 66 cubic inches. So here's your shortcut. You know that surface area is 4 pi r squared. So 256 equals 4 pi r squared. The only way, if you take 4 pi r squared and if you multiply it by 1/3 r, you would get 4/3 pi r cubed, which is the volume. But we don't know what r is. So that's the issue. Okay, nope, we got to do it this way. Not a shortcut. Okay, same thing. Find the volume with a surface area of 400 pi square feet. So 400 pi equals 4 pi r squared divided by 4 pi. You get 100 equals r squared, so r equals 10. So take 4/3 times pi times 10 cubed. And we get 4188.79 cubic feet. Okay, and that goes into Chapter 12. Chapter 12 deals with some probability statistics, and if you want to look into that, you're more than welcome to let me know. I can open up some things for you. It's good stuff to know. We're just going to be stopping at this point. So your assignment starts with some surface area questions. Make sure you know that you're using your radius, not diameter. And then it goes into the volume questions, finding the volume. This question here, question 9, find the volume of the sphere. They're giving you the circumference. From the circumference, you can find your diameter and your radius. Okay, and once you know your radius, you can find your volume. Okay, this is finding volume when given the surface area. Last couple examples. Some composite solids. This is a cone underneath a hemisphere. Okay, then with the volume of that. This is a cylinder surrounded by 2 hemispheres. And then find the surface area and volume of just some common shapes, common balls we have. So that is it. Congratulations. Oops, wrong link. I wanted that one. Okay, very proud of you. All the work you've done, all the time you've put in. I hope this has gone well for you. Maybe if you enjoyed it, we can adjust some things for future math classes a little bit. There are some things I've enjoyed and some things I haven't enjoyed also. But good. Have an enjoyable summer. If you have any textbooks of mine, just hang on to them. Bring them back to me in the fall or next time we see you, and enjoy your time. So send me a message if you get a moment and let me know how you felt the overall class went this fourth quarter. If you liked it, if you didn't like it, I want to know both ways. How can I make this better? So give me some feedback. I'd appreciate that. And we'll see you soon, hopefully. Talk to you later. Bye.